So as we talk about the visualization of 3D objects, we talked about an oblique and isometric sketches, correct? But those sketches, sometimes they do not do a good justice in explaining a 3D object into all of its dimensional perspective, right? And that is why we also introduce another concept, and that is the concept of orthographic views of 3D objects. What this does is we convert a 3D shape and we look at that 3D shape from different angles. We look at it from top, from bottom, from left and right sides, and front and back. And then we convert that 3D object into various views, and each view is called a two-dimensional view. And a collection of all of those two-dimensional views is called orthographic views. Okay, let's talk about that. How do you actually do it? So to best understand, I'm taking an example of a cuboid or a right rectangular prism. And let us assign some dimensions to it so that it is easy to create some relevance. Okay, so height is 2 centimeter and the width is 5 centimeter, for example, and the depth is 7 centimeter. Okay, now this drawing is not to scale, it is only for the purpose of visualization, right? Now let us look at this shape from the top view. Okay, so as you look at it from the top side only, that means only dimensions available to us are the dimensions that we see as I show in the red line, right? So this will form my top view. And how do you actually show it? So the top view can be best described that it is 5 centimeter wide and 7 centimeter in length, right? This will be the perfect explanation of my top view. So this will be 5 and 7 in centimeters. So this is my top view. As simple as that, nothing complicated, right? Next, I'll look at this shape in this direction, the direction of arrow. So if you are standing on the right hand side of this object, of this cuboid, and you're looking at it in the direction of this arrow, then so what dimensions will we see when we look at it from this arrow side? We will look at this dimension, the one which is height, and we will also look at this dimension, the one which is 7 centimeter, the direction of depth, right? So in that case, I can say that my side view contains 2 centimeter of height and it will be 7 centimeter long. So this is exactly what you will see when you look at this object from this direction, right? 7 centimeter and 2 centimeter, and this is my side view labeled as S. All right, now let us look at this object from the front side in the direction of this arrow, the black arrow, okay? And when we do this, what dimensions we are going to see? We will look at the dimension which is the height, 2 centimeter, and we will only notice the dimension which is the width, the 5 centimeter, right? So in that case, I'll say that my front view is the 5 centimeter and the 2 centimeter, only these two dimensions. So this will be another rectangle we will notice, right? Now this completes 3 standard views that come under the category of orthographic views. The top view, and the second is the side view, and the third is the front view. Now this seemed a rather easy example to look at and discuss about the views, okay? Let us look at another shape and define all the views of this shape. The top, the front, and the side view. In this example, I'm going to take a triangular prism. A prism that has a base of 5 centimeter, for example, 7 as length, and each side is of dimension 6 centimeter, okay? All these dimensions are in centimeters, so we will not put those units every single time, just to save time, okay? So as I look at this object from the top side, so this is my top view, what are we likely to see? The first thing we will notice is, of course, a rectangle that has a base of 5 by 7. And at the same time, I will also see this line that is cutting through almost in the middle because this is an isosceles triangle, right? So my top view will contain a rectangle such as this, right? And it will have a dimension of 7 and 5, and of course there will be a line cutting through the middle. It will also appear in my top view, right? So this is my top view. Done with that, right? How simple is that? Now let us look at this object from this side, okay? Once again, I'm likely to see only 2 dimensions. In this one, I'm seeing 7 and 6. So I'll see a rectangle as I'm looking from this direction, the direction of this arrow. Okay, so this is my 6 and this is my 7. A simple rectangle that I'm going to notice from this side. And what will be my front view? The front view that is from this side. the direction of this green arrow. In this case, I'm going to see three edges, one with the 6, the side of a triangle, another 6, the side of a triangle, and then the base of this triangle, right? So my front view will contain an isosceles triangle with the dimension of 5 and 6 each. So this is my front view and this is my side view. So with this, we complete our three views, the three standard views that come under the category of orthographic views of an object. So what we are doing really is, this was a 3D object, right? And we converted the views of this 3D object into the two-dimensional top view, two-dimensional side view, and two-dimensional front view. With that, we will conclude our discussion here, and I will recommend you going into the details of how to calculate the surface area and volume of various polyhedras.